We're going to talk about measurement techniques and guesstimating on ACT math. So measurement techniques are just a way for you to have another tool on the ACT. There's usually multiple ways to solve math problems. The way that's the best way is the one that gets the correct answer fastest for you. Now the reason measurement techniques will work is because although ACT says illustrative figures are not necessarily drawn to scale, the problems are written by mathematicians, and mathematicians are precise. So the reason that the measurement techniques work is because we do know that there's precision involved. The reason ACT says that is in case there is a dispute. If they say this is a 45-degree angle and somebody gets out the protractor and measures it after the test and says it was only a 42-degree angle. And so it's a flawed question. They say, no, we said they're not necessarily drawn to scale. But you can rest assured that they pretty much are. So when you think about measurement techniques, you need a tool with which to measure. Sometimes it can be a measurement pencil where you have marks made into it. I've given these to students before. But notice also, if you don't have marks in your pencil, that the cap of the eraser, or the eraser binding, whatever that's called, probably has a name, has marks on it as well that you could use. For the purpose of our activity, if you've printed the questions, they should have this key from the booklet on them, right? So that booklet number, if you will notice, has ready-made lines, 1, 2, 3, 4, 5, 6. So it can function like a small ruler. You could also use the divisions of the numbers on the test. Anything you can use, you've got these little dots right here you could use in the correct mark. So anything you can use to count is what you should use. I'm going to be using these, so print off or pull an answer sheet and use this as well to measure. It definitely works better on a hard copy than if you were using an online copy. Number 13, in the isosceles right triangle below, AB equals 10 feet. So we know 10 feet is this side right here. And we want to know what is the length of AC. We don't have the length there, so we either need to know the mathematical technique or have a measurement technique. So we're going to use our answer key with that little bubble sheet at the top, and we're going to lay that along the side we know is 10. And then we're going to count the marks. I count 12. We're going to do the same thing along the AC side. Lay our answer key there and count the marks. I count 17. Then we're going to set up our proportion. 10 feet over 12 marks equals how many feet over 17 marks, right? Marks over feet. And we cross multiply, we get 12x equals 170, and we get x equals 141. So now let's look at our answer choices. We know that we can eliminate choice A because it's only 5, choice B because it's only 10, and choice C because it's 20. Now we say, well, is it D or E? Well, D, we know that square root of 16 is 4, and the square root of 25 is 5, and so it has to be between there. So D's out. So 10 root 2 is 14.1, so it has to be choice E. And that's how you use measurement techniques. This would also work if you had the measurement pencil, and with the measurement pencil, I had 10 feet is 18 marks, x feet is 26 marks. I got 13.8. It's not as precise as my 14.1 was, but it's still close enough to work. Just about any tool you have to measure with will work for this technique. Now, another way to solve this is guesstimating. We know that this is 5, 10, 20. We know this is 14.1, and this is between 4 and 5. So now we can say, well, I know this line is 10. So let me either measure with my pencil or piece of paper and draw a similar line along AC. So if that's 10 and that's 10, it looks like I've got a little bit more, not even quite half. So again, we know 5, 10, and 20 are out. It's bigger than 10, it's bigger than 5, it's bigger than 4 to 5, so it has to be 14.1. So guesstimating works just as well without doing the proportion. The fastest way to do this one is to know that an isosceles right triangle has the degree measurements x, x, x root 2. But if you don't know that, now you have another technique to solve this problem. What was a bit harder is 52, and it's harder for a couple of reasons. One of the reasons it's harder is we have this cannot be determined from the given information, and 3.6 and 4.8 are both pretty close. You can use guesstimate to say, okay, this line C to D, I'm pretty sure is longer than 1.2 and 1.8. But is it 3.6 or 4.8? You could probably narrow it down to 50-50, take your best guess. Or we could use our technique. Let's measure what we know. Measure this side, lay down those down and then count the bottom. And I got our side we know is 6 over 10 marks. The side I don't know is x over 6 marks. Cross multiply, I get 10x equals 36. I get x equals 3.6, which is exact. All right, so 3.6 is the exact answer. So our measurement technique worked well on this one. It also works well for the measurement pencil. So I got the known length of 6 is 18 marks. The unknown length is 11 marks. Cross multiply, and I got 3.6. So again, it doesn't necessarily matter what you use to measure as long as you have a common measurement unit. The math way to do this one is known as SOHCAHTOA, and sine of D, 0.8 equals opposite over hypotenuse. You solve for x, which would give you this, 4.8, and then you use the Pythagorean theorem for this triangle to solve for the missing side, which is 3.6. Honestly, that's not a real hard math technique if you know it, but it's also might be faster just to use a measurement technique. Correct way to solve math is the fastest way to get the correct answer for you. Number 22, as shown below, A, B, C, and D are collinear, so they're all on the same line, with B between A and C between B and D. AC and BD equals 12, and BC equals 3. What is AD? So this one you could probably figure out without needing a technique, but if you did, you'd lay your answer key down and count, and then lay your answer key down and count all of them again, and I get 9 marks over 12 equals 16 marks over x. All right, so from here to here, I get 9, and from here to here, I get 16. You solve for x, you get x equals 21.3, which is close to J. And the answer is J. Again, it worked for the measurement pencil. I got 14 marks over the known length of 12 equals 24 marks over x. You cross multiply, I got x equals 20.5. So not the exact same number as I got with the answer document, but it's still close enough to say I know it's 21. And the math way to do this one is just 12 plus 9, because you have to subtract this 3 because you can't count it twice. So that'd be 21. What is the perimeter in feet of the park? Okay, so perimeter. So we're going to take 28 plus 16 plus 40. And then we have this side over here we don't know, but it looks, it's going to be bigger than 16. So we'll say, I don't know, 20 is what I'm going to say, kind of guesstimating. So 28 plus 16 plus 40 plus 20 equals 104. And I look at my answer choices and say, great, there's the answer. Moving on. They put italics here, in feet. So we have to go back up to the paragraph, and it says 1 inch represents 1.5 feet. So 104 times 1.5 is 156. Even if you'd called this length 16, you'd have gotten an answer bigger than 126. You would have gotten 150 actually. So the hardest part of this question is not the math. The hardest part of the question is the reading, remembering to convert it because they have this nice distractor here. So your answer is E. If you had decided to do this one as a measurement pencil, measurement answer key question, it would work too. You count this side, but this is this side, so you want to be a little more precise. You get 8 over 16, so our known inch is 16, 8 marks, 10 marks over x, and you solve for x. You get x equals 20, which is about where I'd guessed. Again, you have to do the same thing, add them up, multiply by 1.5 to get 156. Graphed in the standard xy coordinate plane below is an ellipse. The center of the ellipse is 0, 0. These are the points. What is the distance from A to B? So this is the foci. That's what you're looking for. And so if this, we know the diameter, the vertical diameter across the ellipse is 6. We want to know what's the length from here. So we can probably guesstimate and say, well, I know it's not 6. It's a lot smaller. It looks bigger than 2.4 and bigger than 3. Now you've at least got a 50-50 shot. But you can also use your measurement techniques and measure using your answer key. And I counted, and our known length is 6, 8.5 marks. Our unknown length, 7 marks, x, cross multiply, 8.5x equals 42, and I get 4.9. Now, that's a pretty simple way to do it. You could use the equation for the ellipse and solve it, but it's a pretty complicated solve. By the time you get to 53, you may not have time for that. So a measurement technique might be better on this one. And again, it worked with my measurement pencil. I just had slightly different marks, but get the same answer. I got 4.9, so it was 0.1 off. Here's a question number 58, which is a little bit more challenging because in question number 58, let's look at our answers. We have 37 and 38. Those are close together. 31, 31 and a half. There's not a lot of room for error on this one. So let's use our techniques though and see what we come up with. So if we know this length is 25 and we want to know what is the length of GH. So let's use our answer key and see what we get. So we're going to measure that one and then we're going to measure this one. And I came up with our known distance is 25 and I count 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and a little bit more. So I'm going to say 11 and a half because I have to be a little more precise. I might say 11.25. And then I count 15 marks for a G to H. And so 11.5 over 25 equals 15 over X. And I'm going to solve for X, and I get 32.6. So I know it's bigger than 31. I know it's bigger than 31 and a half, but it seems less than 37. So I'm going to go with G, 31 and a half, which is the correct answer. If I did it with my measurement pencil, I end up getting the same thing. I get 25 marks, 25 known length, 23 marks equals X over 29 marks, and I got it exactly on that one. So even though it wasn't perfectly precise, I got really close. Notice the measurement pencil, I had more marks, so I got a more precise answer. When I used the answer key, my marks were further apart, so I got a less precise answer because I had a less precise measurement. So let's go over another technique we have. You can tear off a corner of a piece of paper. So even in your test booklet, a small corner, just a small one. And now you have a 90-degree angle, right? So this corner makes 90 degrees. Fold it in half. Now you have a 45-degree angle. Fold it in half again. Now you have a 22.5-degree angle. And you unfold it and you can see your marks. So you can use this to solve some angle problems on the ACT. For this question, we want to know what is the degree measure of BDA. So we're going to use our 45-degree paper, and we're going to lay that on the triangle we're looking for, and we're going to see, well, that's just slightly bigger than 45. So slightly bigger than 45, now we can eliminate choices D and E. Doesn't look like it's 88. That's definitely not close to 90. So we're going with 57. Not precise, but probably close enough to get to the right answer, and it is. 57 is the right answer. A little bit of guesstimating, a little bit of tools to help you know what to do. For question 45, what is the measure of angle X? So again, we're going to use our 45-degree piece. We're going to lay it right here. We're going to see, well, that's just slightly less than 45. Not by much, but just a little bit. So we're going to say, well, that's probably C. And again, not perfect, but it gets you what's most likely the correct answer, and it is the correct answer, C. What is the measure of the indicated angle, so here, in degrees? Well, we can eliminate. Let's just use what we can eliminate. We know we can eliminate E, that's 120, that's bigger than 90. We can eliminate D. Now for the others, let's use our 45-degree angle to start with. So use it, put it here. Okay, so we know it's bigger than 45 degrees. Now let's fold it again and use our 22.5. So make a mark on your paper and put your 22.5 here. So 45 plus 22.5 is 67.5. So we know it's less than that. So it's bigger than 45, less than 67.5, has to be B.